All right, so in this video, I'm going to go over orbital diagrams. And orbital diagrams have a specific order that they fill in, and so you need to become familiar with that order. If you can determine that order using the periodic table, the cheat method that I showed you with the S, the P, and the D blocks, then that's great. But if you can't, you just need to straight up memorize it. So it's going to fill 1s and then 2s, 2p. I'm just going to go through some of them, but not all of them. Ignore that dot. That was me hesitating. Okay, that's as far as I'm going to show with an orbital. Actually, let me go ahead and do 4p as well, since it'll fit. Okay, you need to remember that the big numbers right here are your energy levels. The letters are your sub-levels, which is the shape of the 3D shapes that the electrons can exist in. Each one of the sub-levels have a certain number of orbitals. So an S sub-level has 1 orbital. A P has 3, and a D has 5, and an F has 7. So you have these in your notes. But where that translates is, so if this has 1 orbital, it has 1 spot above it because it's an S. P has 3 orbitals, so it's going to have 3. S has 1, this 3. This one has 1. This is a D, so it has 1, 2, 3, 4, 5, and the P has 3. Okay? So from this, you have to be able to fill in with some arrows and follow some rules. So I'm actually going to show you I'm going to do copper, because copper is special. And no, you know what? I'm going to do chromium, Cr. So chromium is number 24, and it's unique in the fact that it's going to help me cover the exceptions as well. So it's number 24, which means in its ground state, I have 24 protons and 24 electrons. So that's what we're going to go with, is 24 electrons. Now for this, you start with your S. You fill up your S completely. 1 arrow going up, 1 arrow going down. That's rule number 1. Electrons are going to spin opposite directions because they're negatively charged and they naturally don't want to be together. They repel each other. And in that repulsion, they spin opposite directions. So one would go counterclockwise and one goes clockwise, and that's just what happens. So we put 2 of our 24. So I'm going to put 2 more. My S's are filled completely first. Now I'm going to go to my P's. The second rule you need to remember is that they spread out first before they pair up. Okay, so first rule, opposite directions. Second rule, spread out before they pair up. In a P and a D, an S, there's only 1, so it doesn't matter. And the third rule is that it goes in this order. Make sure your D's are, 1 number behind. Okay, so I'm going to keep filling them up. Okay, so I'm going to chromium 24, so I'm not there yet. I need 4 more. I don't know why that one's bigger. It just is. Roll with it. Okay, so this is what it is, because if you went and counted all of them, it equals 24. So I'm done, or we think we're done, because anything that ends in D4 or D9 is an exception to the rule. So you kind of have to remember that. So this would be 3D4 right now, because there's 4. So what it does is it gets really annoying, and it takes one of these electrons from the last S and moves it over here. So it really would look like that, and only has 1 arrow here. So it's an exception to the rules of pairing up and filling up this before this, all that sorts of things. It only happens for a D4 or a D9. Now from this, I'm going to write the electron configuration. 1s, there's 2 arrows. 2s, 2 arrows. 2p, 6 arrows. 3s, so forth. Now this one's special because it only has 1. Normally it has 2. And then 3d, 5. Okay, so let me recap really quick because I actually had to pause that video. So we've done our orbital, we've put in our 24 electrons, we've addressed our exception, and we've written our electron configuration like this. Okay, so now from our electron configuration, you need to be able to determine your highest or last energy level that has electrons in it. So these are your energy levels, 1, 2, 2, 3, 3, 4, and 3. So you find the one that has the highest number. So 4. 4 is the last energy level that has something in it, and it has 1 electron in it. So that means I have 1 valence electron, because valence electrons mean electrons in the outermost level. So I have 1. If I were to do the E dot, or the Lewis diagram, Lewis dot structure for it, whatever various name it's called, you take your valence electrons and you put them in dots around the symbol. So here I have chromium. I'm going to put 1 valence electron. Now, if you had something with 6 valence electrons, like oxygen, so I'm going to write out oxygen's electron configuration, just so I have it to talk about. That is a 4. Okay. The last energy level is 2, but I have it in 2 places. So when you're getting your valence electrons, you have to add up both of these. Those little numbers mean electrons. We just add them up, so I have 6 valence. Now, when you go to draw that, you do O, top, bottom, left, right, because electrons want to spread out. So there's 4. Now I'm going to add 5 and 6, and you're going to add the top and then clockwise. So it looks like that. And you should have 2 unpaired electrons left. Something like fluorine, which is 1s2, 2s2, 2p5. Don't stress if you don't know how I'm getting it that fast. That's going to come with practice. The second energy level is 2. It has a total of 7 valence. When you go to draw that, it's 1, 2, 3, 4, and then you pair them up clockwise. And so it looks like that, and that one has 1 unpaired electron. Okay, so we've kind of gone over orbitals, electron configuration. I have videos on how to use this to come up with your electron configuration, but it does not cover the F block. So if you need help with that, you need to come in. How to take this to get our E dot diagram, or Lewis diagram. How to determine our last energy level and our number of valence electrons.